Hi students, now we are going to discuss how to find the Fourier cosine, half-range Fourier cosine series for the function sin x in the interval 0, pi. Okay, here the problem: express f of x is equal to sin x. Sin x is a trigonometric function as a Fourier cosine series in 0, pi. Observe this interval, okay, 0, pi. That means a half range. Hence, show that sigma n is equal to 1 to infinity 1 by 4 n square minus 1 is equal to 1 by 2. Okay. So now, since it is mentioned in the problem, half range, that is here express Fourier cosine series. But observe this interval in 0, pi. So this is a half range. Okay. So it is nothing but the asking to expand or express the function sin x as a Fourier half-range Fourier cosine series. Okay. So now we know that formula, the half-range Fourier cosine series is here f of x is equal to sin x, this given function is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x. Okay. And now here, as you know, what is a naught? A naught is equal to 2 by pi integral 0 to pi f of x dx. Okay. So now here 2 by pi 0 to pi sin x. The given function is sin x. Okay. And now what is the integral of sin x? Minus cos x. So now I'm applying the upper and the lower limit. We take the minus common outside, that's minus 2 by pi cos pi minus 1 minus lower limit cos 0 is 1. So here minus 1 minus 2 into minus 2 4 by pi. Here we got the a naught 4 by pi. Now a n is equal to, what is the a n formula? 2 by pi integral 0 to pi sin x cos n x dx. That is f of x cos n x dx. What is f of x? It is sin x. Now we write this, take this 2 inside. Now we can write this as 2 cos n x sin x. So since we know the formula 2 cos a sin b formula, sin a plus b minus sin a minus b. So if I write like this, 2 cos n x as sin x as a sin n plus 1x minus sin n minus 1x. Okay. Now if I integrate this, what is the sin x integration? Minus cos n plus 1x by n plus 1. Similarly here, sin n minus 1x integration is minus plus cos n minus 1x by n minus 1. If I take the upper limit in place of x for the upper limit, so these two terms become like this, minus for the lower limit cos 0 is 1. So minus 1 by n plus 1, here plus 1 by n minus 1. Okay. So now cos n, since cos n pi is equal to minus 1 whole power n, cos n plus 1 pi is minus 1 whole power n plus 1. Similarly here, cos n minus 1 pi is minus 1 whole power n minus 1. So if I add this to here, okay, if I subtract, I will get 2 by n square minus 1. And I can write this minus 1 whole power n plus 1 as minus 1 whole power n into minus 1. Similarly, this one also, minus 1 whole power n into minus 1. This minus minus plus here, 1 by n plus 1 minus 1 by n minus 1. I took the common minus 1 whole power n here. So this is minus 2 by n square minus 1. Okay. Now here the continuation, 1 by pi minus 2 by n square minus 1 minus 1 whole power n minus 2 by n square minus 1. What is the common? Here minus 2 by n square minus 1 is common, since pi. Minus 2 by pi into n square minus 1 into 1 plus minus 1 whole power n. And here again you can see here in the denominator we have n square minus 1. So that means for n not equal to 1, okay, whenever, as I told you here, in the trigonometric functions in the any interval, notice that here in the, if we get the denominator n square minus 1 like this, so for n not equal to 1, okay, for n is equal to 1, the denominator will become 0. That means the value doesn't exist. Okay, so that for that, this expansion we can take for n not equal to 1, or the remaining values of n. Okay, so now here n is equal to minus 4 by, if n is even, okay, if I put here n is equal to, so this will be 2 into 2 minus 2, 4, minus 4 by pi into n square minus 1. For n is equal to even numbers, for odd 0. But again here n not equal to 1, remember this, n not equal to 1. So here in these cases we need to find this a1 separately. Okay, here we need to find a1 separately. So just by taking n is equal to 1 in this, okay, in this n is equal to 1, taking n is equal to 1, we have to find the a1 separately. Okay, now you are finding the a1 is equal to 2 by pi integral 0 to pi sin x cos x. Take this 2 inside, this 2 sin x cos x can be written as sin 2x. So what is the integral of sin 2x? Minus cos 2x by 2, integral 0 to pi. It's minus here 2, you can take this minus also. This cos 2 pi is 1 minus cos 0 is 1. So this a1 is 0. So now we are getting a1 odd numbers like a1, a3, a5 all zeros, and for the evens we have the values like minus 4 by pi into 2 square minus 1, a4 like this. And thus the half range cosine series is sin x is equal to what is a naught? What is a naught we got? It's 4 by pi. Okay, 4 by pi. So now a naught by 2 is 2 by pi minus 4 by pi into sigma n is equal to 246 cos nx n square minus 1. Okay, so now we got this here, and since here 246 only for events, like means if I take the general, I can just replace, put in place of n is 2n. If for n is equal to 1 means cos 2x, n is equal to cos 4x. That's what they exist, this an for the events. So n is equal to 1 to infinity cos 2n. Let's put n in place of n 2n. Why? Because the value exists only for even values. Yes, okay. So cos 2nx by 4n square minus 1. Now the deduction. For the deduction, what we have to do? Just put x is equal to 0 in equation. Okay. Put x is equal to 0 in equation 5. Put x is equal to 0 in equation 5. So we obtain, so here this sin 0 is 0, 2 by pi. Now we will get, take this 2 by pi, and there you will get pi get cancelled. So sigma n is equal to 1 to infinity 1 by 4n square minus 1 is equal to 1 by 2. So this is what we the required answer. Okay, thank you.